Accelerated Math Analysis, 12.3, Day 2. We're going to finish up our lesson dealing with geometric series and geometric sequences. Number 3, the classic question, the bouncing ball question. A ball is dropped from a height of 30 feet, and each time it strikes the ground, it bounces up to 0.8 of the previous height. So, as we look at our first bounce, we're told that that's 30 feet. It's even pictured over here. So here's our first bounce. The second bounce, well, it's 30 times 0.8. Now, we could very quickly confirm that that's 24. Doesn't take too long to see it. The picture even shows that right here. And you're going to hopefully see something very, very obvious, that you are multiplying by 0.8 each successive time. So this is a geometric kind of a sequence. We know that our a sub 1 is going to be 30. We know that our r is 0.8. And notice what they're asking for part A. How many times does the ball need to strike the ground before its bounce is less than 6 inches? First off, notice the difference in units. We're going from 30 feet to 24 feet and so forth. 6 inches, though, I think all of us would agree quickly, is 1/2 of a foot. So let's go back to this very, very helpful formula for the geometric sequence. We are trying to find the term, the nth value, the value of n, when for the first time the bounce is less than 1/2. So I can put 1/2 over here. My first term is 30. I've got 0.8, and we'll raise that up to the n minus 1. Now, of course, we can divide by 30 on both sides, and 1/2 divided by 30, well, that's the same thing as saying 1/2 times 1 over 30. That's going to be 1 over 60, and here we're going to have 0.8 to the n minus 1. Let me just continue over here off on the far right side. I hope it's pretty clear. We're going to need to take a logarithm. We can take a natural log on both sides, the purpose of which is going to allow us to drop down the power. So I can drop that n minus 1 down in front. Then we'll have ln of 0.8. n minus 1 is equal to the ln of 1 over 60, all over the ln of 0.8. So this is where we can definitely get our calculator out and get some help here, and more or less just type in ln of 1 over 60, close our parentheses, divide that by the ln of 0.8, and we're not going to get a whole number. It's 18.348 roughly. And realize that that's what n minus 1 is equal to. So adding a 1 would get 19.348. So it's on the 19.348 bounce that we're going to have our bounce be 6 inches, being 1/2 of a foot. Now, of course, what you're going to notice in this sequence is our terms are decreasing. We're going from 30 to 24 to 19.2 just in the picture. It's very clear no bounce will really equal 1/2 of a foot. But what we can do, though, is knowing that at the 19.348 term, which there isn't one, that's when we're going to be equal to 1/2 of a foot. We're going to have to say it's the 20th bounce that we're less. And you could confirm that. You could very, very, very quickly use the formula that we started off with. You could compare the 19th bounce. The 19th bounce, you're going to be a little bit more than 1/2 of a foot. The 20th bounce, you're going to be less. To finish up this problem for part B, we want to find the total distance the ball travels before it stops bouncing. Now, this might seem reminiscent of the pendulum problem that we just did. You see, we don't know when the ball comes to rest. We don't know what bounce the ball is finally going to stop bouncing. But we could, as we were talking before, use an infinite series to have a good approximation. Once again, our first term was 30. Our r is 0.8, and the absolute value of r is less than 1. So I could very, very fast say, I know I'm going to converge. I could plug in, here's a 30, divide by 1 minus 0.8, and this is really 30 divided by 0.2, which, by the way, is also the same thing as 30 divided by 1/5. 30 divided by 1/5 is the same thing as 30 times 5 over 1. That's 150 feet. Now, it's at this point we can trick ourselves and say we're done. Here's the problem. 150 feet is not the final answer. Take a look at this picture here. I guess what I'd like to point out to you is that, if we were looking at the 30, well, the 30 would be right here in green that I'm tracing over. The 24, well, you could say, well, it's going to be 24 here, but wait a minute. Here's the problem. The ball not only drops 24 feet, it's going to rise up 24 feet. On the next bounce, it's going to go up 19.2, and it goes down 19.2. So you can look at the nature of this bounce and say, well, wow, it looks like you're going to go up 24 feet, down 24 feet. It's very, very, very tempting to say, I know how to fix this. I'm going to go 150 times 2 and say that we've got 300 feet. Now that sounds wonderful. The only problem is, if you look at the picture again, you can see that, yes, generally we do have a bounce having so many feet going up and so many feet going down, but there's one bounce where it doesn't occur to have a bidirectional kind of a situation going up and down that same distance. It's the first one. See, we drop down 30 feet. We never bounce up 30 feet. So to compensate, we're going to have to subtract the 30 here. We doubled what we'd have, but we're going to subtract 30. The answer is 270 feet. And that's what we're going to have for the total distance traveled. One last problem. For number 4, find x so that these terms are consecutive terms in a geometric sequence. We've got our first term, our second term, our third. And, if you want to find your r is going to be the common ratio of successive terms. So we could say x over x minus 1 is your common ratio. Similarly, we can say x plus 2 over x is going to also be a common ratio. But if we really have a geometric sequence, that common ratio is always fixed. It's always the same, you see. So we'll have x over x minus 1 equals x plus 2 over x. To finish this up, let's cross multiply. We'll have x times x. Here we'll have x minus 1 times x plus 2. And we'll have x squared. And, here we could get our x squared plus a 2x minus a 1x and then minus a 2. By the way, I hope you can see our x squareds are going to cancel out. I could subtract that. 2x minus 1x is just an x. Add a 2 and you'll get x equals 2. That's your answer for number 4. Never hurts to check that you do have a geometric sequence. Plug it in. 2 for x. 2 minus 1 is a 1. Here you have a 2. 2 plus 2 is 4. You've got the pattern 1, 2, 4. That is a geometric sequence.